Good afternoon, everybody. Welcome to, I think, the final talk on the final day. I'm Matthew Fisher, and I'm an infectious disease epidemiologist. I study diseases, and I study diseases caused by fungi. And I'm going to be telling you a mystery story today that has kept me very interested and excited for the past 15 years. And this mystery story involves a fungus, but it also involves a frog. And during this exploration, I've become fascinated by frogs because they're just the most wonderful organisms in the world. And this is our Australian tree frog, Jill. She lives at home with us. And she's a beauty, and I'm obviously a beast. Frogs are incredibly important. We find them all over the world, apart from Antarctica. And in some parts of the world, they're the principal vertebrate biomass. So you can literally have more frogs in an environment than you have deer, for instance. And those frogs provide many ecosystem services. They eat all those nasties which parasitize us. So the mosquitoes that are trying to transmit diseases, they're just devoured by those predatory frogs. They'll eat many other disease vectors. So we love them for that reason. But they're also an integral part of the food web. So if you imagine frogs, let's call them amphibians as well, they can be tadpoles. So in that case, they're behaving like little kind of mini sheep grazing in streams. So they go chomp, 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 chomp across the bottom of the stream, and they clean up all those algae. And then they hatch into, they metamorphose into frogs, and at that point they become food for everything else out there. So imagine what those storks are eating as they go through the wetlands. They're just picking out the frogs. So if you take away frogs, the birds go hungry, snakes eat a lot of frogs, snakes go hungry, and they're an integral part of that food web. We love them for that reason. They also have quite stunningly cool biology, and so much mystery exists in their life cycles. So these are the gastric brooding frogs from Australia. And there were two species, a northern gastric brooding frog and a southern gastric brooding frog. And what these frogs did is they'd lay eggs, they'd fertilize their eggs, and then they'd eat their eggs. Their eggs would go into their tummy. But they're not going to use those eggs as food. What they do is those eggs have got a chemical around them called a prostaglandin, which shuts down hydrochloric acid production, so the eggs hatch in the stomachs of those frogs and become little tadpoles sheltered from the world, just wriggling in their tummies. And eventually they change into little froglets, and blah, the frog vomits out a perfectly formed baby frog. I mean, just... So imagine that incredible biology. There were two species. They both went extinct in the 1980s. Bang, we lost them forever. And I'll tell you why later. Frogs are also amazingly beautiful. I took this picture recently in Madagascar. There's a Buophis eleni sitting on a branch, and that lady behind is there just to see the frogs of Madagascar. There's hundreds of species, and they're completely amazing. So frogs are worth a huge amount of money to countries just in attracting people. And young people just are fascinated by amphibians. I mean, I think we probably all recognize our first encounter with an amphibian. I mean, for me, it was a little loch above Windermere in the Lake District where I caught a newt, probably aged about 5. This young chap here is Danny, and he's sitting in the front row right here. A little bit bigger now. But he's doing what all kids do, is guddling tadpoles and eggs out of ponds. So they're just very, very cool animals. This is a poison dart frog. We've had a young princess born in England, Charlotte. One day she'll want a prince, and she might do what princesses want to do, and that's to kiss a frog and try and conjure up her own prince. You probably wouldn't want to do this with one of these, because each one of these poison dart frogs has enough poison to kill 10 humans. So your princess would swoon, and she would never meet her prince. So they produce batrachotoxin, which is an incredibly sophisticated toxin. Some of these molecules are now being used as anti-cancer drugs. So we love them. It's not just frogs we're talking about here. Amphibians, there are almost 7,000 species. So there are more species of amphibians than there are birds, vertebrates, other vertebrates, animals. There's 9,000 species of birds. So they're very, very species rich. And a lot of them look like this. They're Sicilians. They zoom around like earthworms under the forest leaf litter. But they're actually amphibians as well. And of course, there are the salamanders too. So great animals, great biology. They're widely spread across the world. But the amphibians, and specifically the frogs, are in a lot of trouble. Why are they in a lot of trouble? Well, we know this. Well, first of all, we know they're in a lot of trouble by this very, very unique and precious organization called the IUCN. And that's shorthand for the International Union for the Conservation of Nature. And what the IUCN do is they're like doctors that provide a health check on the world. And they'll look at species and say whether they're okay or whether they're getting rarer and we need to be worried about them. So what the IUCN does is they'll basically sit down, get a bunch of experts to sit down around a big table, and they'll talk about the species that they're interested in. And they'll apply criteria, and they'll basically say, well, when did you last see this frog, Professor Fisher? And I'll say, well, I was in the Amazon rainforest and I saw 10, but the year before I saw 100. They seem to be rarer. Or I might say, well, actually, there's so many, I couldn't step out in my tent without rolling over, frogs all over me. So in that case, it would probably put a nice ranking of least concern. So many species are of least concern. Some species are getting rarer and they're near threatened. And then the IUCN categories, and this all comes under their red list. Their red list is the health check of the world. Critically endangered is what we don't like to see. And then, like those gastric brooding frogs, some of them become extinct in the wild. That means they're gone forever. Some frogs, and I'll be talking about those later, are extinct in the wild, but we still have them in places such as zoos. So the IUCN provide a very valuable function in assessing how healthy species are. And this is one of their kind of assessments of broad groups of animals. So if we look at birds here and mammals, birds as a mammal, and this is from the 1980s, so that was way before lots of you children were ever born, up to the present. And one up there is completely healthy, and 0.7 down here is the species are in those not good red list categories, the red ones. Frogs are very threatened. They're low down and they're trending downwards. I don't know the story behind corals, but they look pretty bad. But let's just focus on the amphibians. They're more at risk than the birds and the mammals. So, why? Why are frogs becoming rarer at a rate that's greater than other big kind of animals and birds? Is it because we're chopping down rainforests? Well, that's part of the question. Is it because we're taking lots of them out of the wild and putting them in cages, so over-collecting them? That's also part of the problem. But there's something else there that we didn't understand. And it was basically in the 1980s that scientists started all getting together and going, this chap in Australia says, they can't find this species, and this chapette in Africa said she couldn't find this species. They seem to be getting rarer, but all over the world. And this is where it got interesting, because these were enigmatic declines. We couldn't find a cause for these species becoming rare. The forests looked lovely. They were full of toucans and slithery snakes and gorillas. But suddenly, there were no frogs. It was completely enigmatic. And this chap here, the Costa Rican golden toad, was just a real big signifier of this process because they're completely unmissable. I mean, it literally is a toad that looks like it was dipped in gold. You know, you could see it a mile off. And there were small populations of them, but lots, hundreds, and then boom. One year they just weren't there. We didn't even find any dead ones, but what happened to these golden toads? So they became completely extinct in 1987. And so, you know, these biologists, these people who are interested in amphibians, herpetologists, started looking a bit more closely at the places in the world where these declines were happening. And the two places where they were most clear was Australia and Central America. So this is a map of Central America, and that's the north where the Costa Rican golden toad suddenly went missing. And then what we noticed is that as you go from the 1980s through the 1990s to the 2000s, amphibians started going missing in a big sweep. And when you see a wave like that, then you start to think that actually this is probably a process such as an infectious disease, because we know that infections, if you've got a cold, you'll give it from one person to other. You know, we see this with something like Ebola. It's a wave-like spread. This looked like an infection. David Attenborough was there. He filmed the last wave of this golden frog, Atelopus zatiki, in Panama in 2008. They used to hold territories by waving their hands to scare off other males. They watched that species die. So we still have it, and I'll talk about those golden frogs a little bit in a minute, but they watched them be lost. So this is where we circle back to actually what I do for a living, which is to study fungi that cause disease. And it was a fungus amongus. Batrachochytrium dendrobatidis is the horrible name that was given to it by a little old lady who finally gave it its scientific name. It's so impossible to say that, we call it BD, or chytrid. And it produces these little swimming zoospores which zoom around and they get into frog skin. And because frogs breathe through their skin, they take in water through their skin. Once you have an infection in their skin, then some species become very sick very fast and die. And then these little tadpoles develop and they zoom around, and you get a cycle of infection. And it was this chytrid which was driving these enigmatic declines. So once that was identified in Central America, in the species that we saw there, like those golden frogs that David Attenborough was filming, we started to find this chytrid in other parts of the world. And it was obvious because it was causing very bad things to happen. So this is the mountain chicken frogs of Montserrat and Dominica. They're so called because they're huge. They're the size of chickens, and they taste almost exactly like chicken. And they were the national dish, so much so that they appeared on the flag of these countries. But when chytrid arrived in these islands, boom, those animals went extinct in around about 6 months. So they were very obvious declines. And then also in the Sierra Nevadas of America, those chytrids got in there, and they caused declines in these mountain yellow-legged frogs, which went from very numerous to very rare very fast. So there's been a lot of work in scientists going around the world and trying to find these chytrids, where they are, where they're not, and what do they do. So I'm just going to show a little movie now which describes a not completely typical field trip, but it'll give you a flavor of how you actually catch these chytrids in the wild so that you can bring them back to Imperial College and to do our various experiments on them. So, it's working. So you choose your place that you want to go. We wanted to go here in French Guiana, central of the Amazon rainforest. You see there's no roads there, so you've got to figure out how you're going to get there. You pack your bag, you buy a boarding pass, and that takes you to the city where you've got to get into smaller forms of transport. There's a very jolly Frenchman here, Claude Mio. He's a French professor. And then you have your other research people with you. Elodie, she's French, and Priya, she works at Imperial College. And then you have to get into this flying machine, and things get really quite scary, because you realize the pilot was put on Earth for two reasons. One was to take scientists to research bases, but the other was to frighten them as much as he could on the way there. So, you know, he could be flying far above the rainforest here, but actually he's flying along the river, pretty much as close to the water and trees as he can, because he just wants to scare the pants off you. He wants you to arrive there just not feeling very good. And, you know, it doesn't matter if it's belting down with rain. It's normally belting down with rain in rainforests. He'll just bring this helicopter in, and he'll drop it into this little clearing in the middle of the rainforest. And, you know, it's just a day's work for him. He's got to make it exciting. But is he going to get out of his helicopter and help you unload? No. He gives you an anorak, and you've got to do it yourself. Once you're there, it's pretty good, because they've put up some tarpaulins to keep off the rain. And because it's a French research base, at least the food's good. I mean, mostly tins, as you can see, but hey, you know, anything's better than nothing. But then you realize that you're in this incredible rainforest. It's just full of calls of frogs everywhere. And the first few days are not very good, because you can hear the calls, but you don't catch anything. Elodie's been there before, and she started to catch. And so these are these dart frogs. Very poisonous, very beautiful, and just extraordinary. Alabates femoralis. We caught about 20 of those. They're so difficult. These are the Atelopus. Look at that beautiful eyeliner. They were a bit easier to catch. And here's Ranometa amazonica. Very, very small, but again, just delicious. Beauty and the Beast. You can decide which one's which. That's a very big Bufo gutturalis, a toad. So you catch frogs and toads all day, and then all night you sit there with the mosquitoes buzzing around your head, and you're catching your little chytrid samples from the animals you caught in the day. So you're working with these agar plates, with little tubes, with needles, it's not easy. It's not all hard work. Occasionally you lie on a rock and you look over the rainforest, and before you know it, he's back. It's time to go home. You know, look at him. He's a complete looper, isn't he? Again, he plays this trick. It's actually raining heavily now, so, you know, it doesn't bother him. But look at this wonderful rainforest. I mean, they say the rainforests of the world are being chopped down. Perhaps they are, but this just looked absolutely wonderful to me, and there was so much of it. God bless France, really, because they're looking after it very well in French Guiana. So we're back in Imperial, and it worked. This is the fungus that we collected. It's chytrid zoospores inside a zoosporangia. Out of the 400 animals that we caught, we got it to work twice. So we were so close to the entire trip being a failure, but 2 is 200% better than 0, in my book anyway. And that means that we can now work on that chytrid from French Guiana. We can write our glossy research papers in glamorous journals, justify to our funders that we've been doing a good job. At that point, the world's press open up to you. You can go on radio, television, and take selfies in places like that radio studio. Job done. So that's one research trip in a tropical rainforest environment. But this is the really curious thing about chytrid, is it's not just in those rainforests which is causing a problem. And we believe it is in French Guiana, because research scientists are, talking about species that you used to hear calling a few years ago, and they can't hear them calling anymore. But a place where we've really done a lot of work over the past decade are the French Pyrenees. If you've ever been to the western French Pyrenees, you should really go, because they're most extraordinarily beautiful mountains. A lovely French village here called Lescun that we work from. And the species that we love to study here are these midwife toads, Aletes obstetricans. So they've got a lovely biology. The females lay the eggs, but they're then just like, well, it's going to be really hard work looking after those. I'm going to give them to my husband to look after. So the husband takes the eggs, and he's very domestic. He does what he's told. He wraps those eggs around his legs, and he looks after them for 6 months or so. And she just goes off and parties. So that's the male. It's not a horrible disease. He's carrying the eggs. So, it's a beautiful place, and for millennia, those frogs have just been there in the Pyrenees going through their natural cycle, and there are, large numbers of them. It's a very healthy population until, it's kind of gets a bit depressing to say it, but it's the truth, chytrid got there. So these are the lakes that the midwife toads breed in, and you get, the year is very short up there. It's only not snowy for about 3 months that they can get out and do their business and grow their tadpoles up. And you have these huge swarms of tadpoles. Well, that's what you like to see. But what we do there is we go and we'll walk around these lakes and we'll look to see whether or not we find healthy or unhealthy midwife toads. And all too often, we see this sight. The animals go from being tadpoles, healthy tadpoles, but infected with chytrid, and when they go into their toadlets, then they start to die. And we'll often find these very sad sights of just picking up piles and piles of dead midwife toads in a day. It's just extraordinary what this disease has done right across the planet. I mean, Ebola was terrible, but it was a little part of Africa that was infected, and, this disease that we see here is, we found it on every continent that we've looked for. So, but then you can actually start to do some science and say, well, how much of a problem is this disease in these lakes in the Pyrenees? And, this is why being a biologist is a fascinating job, because there is no clear and easy answer to it. What is kind of encouraging is that in other parts of the world, we've seen complete loss of species into those red list extinct categories. But here, it doesn't actually look like this is happening. So, this is Frankie, a PhD student, gently dip netting tadpoles out of the lakes. And then we'll give them this little mark that fluoresces under a UV light. So we can mark animals, and we can do this. We can literally count them. And for year after year, we count these animals to see if they're declining, or they're stable, or hopefully going up. And what we find in some lakes, chytrid is expanding across this region. So we caught the problem quite early. We see these steep declines in some lakes, Lac Anthibert and Lac Lers. But this lake here, Lac Puig, you can see a very encouraging increase. And in another lake that we first found the infection in Spain, there's now so many animals we can't count them. So it looks like they suffer a hit from chytrid, but then they recover. And we don't know what that recovery is caused by. But we do know that there are things in the lakes that can occur, that can help populations survive chytrid. So one of these experiments, which I'll just briefly tell you about, was the infamous donkey water experiment. So what we did here was that we spent a long time getting these donkeys up to these mountain lakes and taking the water down. And when we got this water down to the laboratories that we use in that area, we'd then test whether or not what was in the water could kill the chytrid zoospores, those little swimming stages that I showed in that short movie. And we actually showed that there were these little organisms that chomped the zoospores. And these are the water predators. They look a little bit like the water crustaceans Daphnia that swim around the water, and they actually predate on those chytrid zoospores. So the chytrid is stained in blue here, and you can see these paramecium species are just literally gorging themselves on this feast of zoospores, which is great because every zoospore that they eat is one less that can go and infect a frog. So we believe that these micro-predators are a really important part of the story in controlling the chytrid quite naturally in some of these high-altitude montane environments. So what kind of explains this worldwide occurrence of a nasty disease which affects amphibians? So a long, long time ago, the world looked like this. You had, a fungus here, fungal species there. I mean, just like the amphibians, everything had its place. There was a series of niches with their different fungi in them. It was how it had always been until humans came along. And what we do is we move things around a lot. We're very good at picking something up here and moving it there. So, I mean, that's certainly, we trade amphibian species. If you think that I've got Australian tree frogs sitting in a vivarium in North London, obviously we've been moving frogs around. And we believe that that movement of amphibians has been spreading these horrible chytrids. So this has got a special word. It's called pathogen pollution. And we believe that places like Central America and Australia didn't have these chytrids before we moved them there. And it was about the 1980s that they were introduced, and then these chytrids were polluting the environment and spreading through the amphibian populations there. So this isn't a story that has an end, unfortunately. It's something that's continuing to occur, and it's changing as we go along. So we thought we understood a lot about chytrid. Like I say, I was working on it for 15 years, and there were people even before that, and we understand where these different chytrids occur. But then, suddenly, there was a new kid on the block, and this was a chytrid that didn't kill frogs, but just killed salamanders. So this was discovered 2 years ago. So it was 2011 was when it was first described. And it was had to be given a new impossible name, Batrachochytrium salamandrivorans. We call it B-sal. And this was discovered in Belgium and the Netherlands, where it was killing fire salamanders in great numbers. And through the genetics that we did, we showed that it was a completely new chytrid infection. And this is through, again, some genetics, we showed that this was a very clear example of pathogen pollution. This chytrid occurs in these Asian fire-bellied newts all over the landscape in Vietnam and Japan, and it's been spread to Europe, where it has somehow got into the environment where it starts to cause a problem with the fire salamanders there. So why is that a problem for us in the United Kingdom? Well, we don't have these fire salamanders. I mean, they're a beautiful species, but we only find them on mainland Europe. We're an island. I'm not sure whether we ever had fire salamanders. But we do have great crested newts. And some of the scientists that have worked on this shows that this chytrid is a real problem for great crested newts, which are a species which are highly conserved in the UK. And recently, we found this chytrid infecting 2 populations of amphibians in England. Not in the wild, but in captive collections. So what has happened there is that that chytrid has been brought into the UK on amphibians that are being traded as pets or in zoo collections. So this is a problem because although it's in captive collections, if it did get into the environment in the UK, then it could be a problem for the species that we absolutely love, the great crested newt, and that we actually, under European law, have a duty to protect. So this is a really, really tricky problem. It's a biosecurity problem. Biosecurity is when there's something here that you know about that can cause a problem and you don't want it here. So you have to find mechanisms and ways of preventing it from spreading. So, once you know about a pathogen that causes this disease in great crested newts, you don't want it to be released into the environment in the UK. So what are we actually importing into the United Kingdom? In fact, what are we importing everywhere over the planet? It's an interesting question. The answer is we're importing and exporting a lot. We don't actually know what we're exporting or importing in detail because we haven't described many of these species. But these arrows with our little island in the middle just show all the amphibian species that we're moving into this country from around the world. And there's some red lines there which show that we've actually detected chytrids in those importations which have gone through the Heathrow Animal Reception Centre. So we don't actually have much biosecurity in those animals, those amphibians, those frogs, those salamanders that we're bringing into the UK for trade and for pets. And that's something that we really need to have a very long, hard thought about, and also discussion with the government about whether or not we should be doing this importation of animals that have these horrible chytrids on them. So that's all a bit gloomy, isn't it? It's not all bad news. And what's incredible about this amphibian research is that people are able to come together and to find solutions in the places where it matters. So I mentioned this golden frog, Atelopus zatiki, in Panama. These people are fighting the chytrid fungus by looking after these animals. You can't look after them in the wild anymore because the chytrid's there just waiting to nobble them. So they've come up with a very innovative solution. So ships all around the world are moving these shipping containers. Usually at Christmas time, they're full of kind of Nintendo Game Boys and I don't know, cuddly panda bear-shaped toys and whatever else, Christmas cakes. But actually, they can be co-opted for other very useful purposes. It's not a shipping container. It's been converted into a biosecure frog breeding pod. And scientists have filled it with these cages. They've got these golden frogs breeding in them. They've got a nice, secure environment. The chytrid can't get in. And they're making these what are essentially captive assurance colonies for those amphibians, which are extinct in the wild. And it's a wildly innovative solution, and we can just literally drop these shipping containers into a rainforest with a helicopter, and they're ready to go. And, so people are getting together, and zoos around the world are spending millions of dollars in actually equipping these shipping containers and setting up these essentially kind of micro zoos for the amphibians that aren't there in the wild anymore. There's some trickiness about figuring out the biology of the species so that you can breed some of the trickier ones, but, as long as you put enough energy into it, you can get there in the end. So I've told you a lot about this, but there is things that we can do so that we can stop frogs being imported with disease and spreading their diseases. We can find out new ways of looking after them and keeping them out of the environment until we've figured out ways of using, chytrid zoospore chomping micropredators to control them so that we can have these happy frogs going through their normal lives. And it's not that there's just lone scientists like me scattered around doing this work. There's huge organizations, and this is where the world gets really good, is because there's so many people that are concerned about wildlife and will pull together to actually work to conserve species and to put them on the radar of governments and so on, so that we have a chance of recognizing problems and finding innovative solutions to dealing with them, so that we have a world for you children that's also full of happy amphibians zapping their bugs. We don't like the bugs, but we do like the frogs. And we moan about our research organizations and not having enough money, but our Natural Environmental Research Council has funded me for the last decade, and without that, none of what I do could go forward. And actually, who pays for the NERC? It's you, out of the tax that you pay. So thank you very much for helping me to save the frog. That's all.